We have learned to solve linear systems by graphing. Today we're going to learn another method of solving a linear system. We're going to solve by substitution. Before we get into the process of solving using that method, let's actually set up a linear system based on a scenario. Now I've already read this problem through a couple of times, and you should be willing to do that. It almost always requires more than one reading of the problem to fully understand it and set up an equation that's based on what you've read. So let's read through this one. Monica built a porch that contained 2 different colors of bricks to create a nice pattern. She purchased the red bricks at $2 each and the gray bricks at $3 each. I like to underline that information that I feel is going to be important when I'm setting up my equation. So red bricks at $2 each and gray bricks at $3 each. We want to know how many red bricks did Monica purchase if she spent $160 on 60 bricks. So it looks like we have money, and then we also have a counting part. First, let's identify our variables. We don't know how many red bricks, so let's assign a variable to that. I'm going to use R, but you can use any letter you like. For the number of gray bricks, I'm going to use the letter G. So I need to write 2 equations, one for the counting, and then the other one for the money. We know that she had 60 bricks in total. We don't know how many of those were red and how many were gray. But if we add the number of red bricks and the number of gray bricks, we know we're going to get 60 altogether, and that gives us our first equation. The second equation is going to be based on money. How much money did she spend on red bricks? Well, she spent $2 for each brick, but we don't know how many bricks. So we're going to multiply that $2 times R, which is the number of red bricks. Then we're going to add to that the cost for gray bricks. 1 gray brick costs $3, and we don't know how many, so we're going to multiply by G, which is the number of gray bricks. We know that she spent $160 in total. So everything in the second equation deals with money, and that's how you can. Let's set up our next scenario. Mr. Middleton is contemplating which chauffeured car service to take to the airport. The first costs $10 up front, that means just to pick up the car, and $2 per kilometer, so that value is changing. The second cost $4 plus $3 per kilometer. For a certain driving distance, the 2 companies charge the same total fare. What is the distance? What is the total fare? These are the things I'm looking for: distance and total fare, which means cost. So that's what my variables are going to represent. You can use any letters that you want, but it's important that you identify them so you don't forget. I'm going to let x equal the distance, and our distance here is in kilometers. And I'm going to let y equal the fare. I like the word cost better. I understand that better, so I'm going to say cost. One equation is going to be based on the cost for the first company, and the second equation is going to be based on the cost for the second company. Both equations are set up using the same logic. So the cost of renting the vehicle is going to equal the beginning cost. That's the cost up front, just to pick up the car, plus a charge for the distance. So that's going to be the cost for the distance, which is in kilometers, multiplied by the number of kilometers, so multiplied by the distance. Our first equation will be y for the cost is equal to the beginning cost for company 1, which is $10, plus the cost per kilometer, which is $2, multiplied by the number of kilometers, which I'm calling x. The second equation is set up the same way, but for the second company. So the cost for the second company is going to equal $4 to pick up the car, plus $3 times the number of kilometers. Now let's look at the process to solve a system by substitution. First, remember that there are three results that we can get when we solve a system, whether it's by graphing or by substitution. We might get one solution, we might get no solution, or we might get infinitely many solutions. Our first step in solving by substitution is to solve for one of the variables. We want to pick the easiest variable to solve for. So if we look at example 3, the easiest variable to solve for is this x right here, because the only thing that's happening to it is that it has a plus 6y. If we solve that for x, then we just subtract 6y from both sides and get x equals 4 minus 6y. Now I'm going to substitute the expression that I have for x into the x of the other equation and solve it for y. That looks like this. So I'm working on the first equation. I have 4 times x, but instead of x, I'm going to put the expression that I found for x, 4 minus 6y, and then finish writing that first equation. Minus 3y equals negative 11. Now I have an equation that only has y in it, and I can solve for y. I need to distribute the 4. 4 times 4 is 16. 4 times negative 6y is negative 24y. Then I have minus 3y equals negative 11. I can combine like terms. Negative 24y and negative 3y make negative 27y. The 16 just comes down because it doesn't have a y attached to it. Now we can subtract 16 from both sides. I get negative 27y is equal to negative 27. Divide both sides by negative 27, and y is equal to 1. The final step is to take that value for y and substitute into any of the equations above to find the x that goes with it. Now this is going to be the easiest equation to solve for x because it already has x on one side. I just need to put a 1 in for that y. So I have 4 minus 6 times 1 for the y, and 4 minus 6 is negative 2. So my x value is negative 2 in my ordered pair, and the y value is 1. Remember, x always comes first, and then the y. Let's try that again on example 4. We want to choose the easiest variable to solve for. I'm going to choose this plus b. Now it doesn't have to be that one, but that's the easiest one. To solve for b, all I have to do is subtract 2a from both sides. So b is equal to negative 8 minus 2a. Now I'm going to take that expression for b and substitute into the other equation. So the other equation starts 4a minus, and then instead of b, I'm going to write this expression that I found, and that's going to be equal negative 4. So in this group for b, I take out the b and I put in negative 8 minus 2a. Now I need to solve for a. Distribute to get rid of the group. There's a minus sign in front of the group, so I have to distribute a negative 1. Negative 1 times negative 8 is positive 8, and negative 1 times negative 2a is positive 2a. I can combine the 4a and the 2a and get 6a plus 8 equals negative 4. Subtract 8 from both sides, and 6a is equal to negative 12. Divide both sides by 6, and a is equal to negative 2. Now that I know what a is, I can take that value back up here and substitute it in and find the b that goes with it. So b will equal negative 8 minus 2 times a, but a is negative 2, so I'm substituting in that value. Remember, you have to multiply before you can add or subtract. So negative 2 times negative 2 is a positive 4, and b is equal to negative 8 plus 4, which is equal to negative 4. So A equals -2 and B equals -4 is the solution to that linear system. Pause the video right now and try that on example 5. So I got an x value of 0, and then I took that 0 and substituted into the equation where I had solved it for y, and I get y equals 4. Remember that 0 is just a number like any other number, and so it is a valid solution. But let's see what it looks like when we're solving by substitution and the result is no solution. We don't know in advance that this is what's going to happen, so we just start like we normally would. Let's pick this y right here because it's the easiest thing to solve for, and let's solve for y. Y is equal to 4 plus 3x. So if I take that expression and substitute into the other equation, I get 6x minus 2 times y equals 3. Go back and substitute the 4 plus 3x for the y, and then solve for x. 6x, and then I have to distribute this -2, so -8, and -2 times 3x is minus 6x, and that equals 3. Notice what happens when I combine these like terms. 6x minus 6x is 0, so I don't have any x's left, but I still have this -8. I don't know why I wrote 2 8s there. I still have the -8 equals 3. That's a false statement, and when we get a false statement, that means that there's no solution. Now there's a difference between my variable canceling out to 0 and getting an answer of x equals 0 like we did in the previous example. So don't get those confused. If your variable goes out and you get a false statement, then that's no solution. Let's see what it looks like to get infinite solutions. Pause the video and solve this system using substitution. In this case, our variables canceled out to 0. I had a -6y and a positive 6y, so no variables are left after I do the substitution. But I get a true statement. -15 is equal to -15. If I don't have any variables left, but I get a true statement, then that indicates that there are infinitely many solutions. And we know from our graphing that that means that these equations represent the same line. Good luck on your practice, and ask questions if you have any.